There is a solution that can reduce your fuel costs by up to 20%, yet 99% of factories still don't know about it. Sounds hard to believe, right? Watch until the end of this video, and you'll understand why. This is a very familiar sight in factories that use steam boilers. Steam is released into the environment, and most people consider it completely normal. But turning cold water into steam, only to release it into the air, actually consumes a significant amount of fuel. So where is the loss happening? Let's take a closer look. In most factories around the world, the steam process follows a similar pattern. Steam is generated in a boiler, delivered into the system, and passed through heat exchangers to serve production needs. For example, drying, sterilization, ironing, food steaming, or heating other environments. Steam is typically used in two ways, direct and indirect. In direct use, steam is injected straight into the product, like steaming buns, rice paper, or cooked rice, where it mixes with the product itself. In indirect use, steam transfers its heat and then condenses back into water. This condensate is usually returned to the boiler for reuse. However, it is still very hot, often above 100 degrees Celsius, and still contains a large amount of energy. When this hot condensate is discharged into an open tank at atmospheric pressure, part of it flashes into steam and escapes. This is where energy loss occurs. So how significant is this loss? Let's assume steam enters the system at 8 bar. After heat exchange, the condensate remains at around 4 bar. At this pressure, its temperature is about 144 degrees Celsius. This condensate is then pumped back to a feed water or deaerator tank. If the volume is small, cold water in the tank can cool it below 100 degrees Celsius, preventing evaporation. However, in reality, to cool 1 cubic meter of condensate from 144 degrees Celsius to below 100 degrees Celsius without flashing, you would need about 10 cubic meters of cold water. For example, a 10-ton boiler with a 40% condensate return generates 4 cubic meters of hot water per hour, requiring up to 40 cubic meters of cold water to cool it. Meanwhile, the actual makeup water supply is only about 6 cubic meters per hour. This means a large amount of steam will inevitably be lost to the environment. But if we maintain the condensate at 4 bar and 144 degrees Celsius and pump it directly back to the boiler, this energy loss can be completely eliminated. The key question is, how do we maintain that pressure and temperature? The PCHR system by DV solves this problem with a proprietary technology, validated by a $100,000 award from USAID. For this system to work effectively, 2 main challenges must be addressed. First, maintaining condensate pressure without disrupting plant operations. Second, safely pumping high-temperature water back into the boiler. The PCHR system has been implemented in many factories across different industries, delivering clear results. For example, at Shiseico, Saomai Group Anjung, after installing the system on 2 15-ton biomass boilers, fuel consumption dropped from 200 kilograms to around 165 kilograms per ton of steam. That's a savings of about 20%. In addition, a 15-ton boiler can now operate smoothly at up to 16 tons. However, if the condensate return rate is below 30%, the benefits may not be significant. If it exceeds 30%, the payback period is typically less than 6 months for continuously operating systems. If your factory is recovering condensate but not aware of flashing losses, it's worth checking. You could be losing money every hour without realizing it. Thank you for watching. If you found this useful, feel free to share.